let's talk about our last thing for today's lesson, and this is called a start plus accumulation problem. Now, this problem takes the fundamental theorem of calculus, which is what we were just doing. So take the antiderivative and then plug in the limits and subtract them. And it changes things around a little bit by adding f of a to both sides. So now I get this equation, where f of b equals some starting point plus the integral from the starting point to the ending point. Now, let's talk about a couple things. So this is a variation of the fundamental theorem of calculus, and it is an extremely common AP type of problem. So let's look at an example of this. So I know that f prime is this and f of 0 is this, and I want to find f of 2. Now there are two totally different ways we could do this. Method 1 uses stuff that we've learned already. So with method 1, here's f prime. Let's find f of x by taking the antiderivative. So this is going to be 3x cubed over 3 plus 3x plus c, because I don't have any limits on it. So this is going to be x cubed plus 3x plus c. So I found my antiderivative. That's step 1. Step 2 is to use the point given to find your c. So 0 cubed plus 3 times 0 plus c equals 4. So now I know c equals 4. So now I have my equation, x cubed plus 3x plus 4. And then step 3, now that I have an equation, I can find f of 2 by plugging it in. So 2 cubed plus 3 times 2 plus 4. So f of 2 is going to equal 18. So that's method 1, and that's just using everything we have already learned how to do. Find the antiderivative, find c, and then actually find f of 2. Now let's talk about method 2, which uses the start plus accumulation. So that law says that if I want to find f of 2, let's zoom out again so we can kind of see it up there. Here, actually, better yet, let's copy it down up here so we can use it for all our problems. There we go. Okay, so if I want to find f of 2, so b is 2, I'm going to take f of 0, which is the other point they give me, so a is 0, plus the integral from 0 to 2, from the point they give me to the point I want to find, of f prime, so my equation, dx. Now let's try this. So we're trying to find f of 2. Let's see, f of 0 is given to us. We know it's 4. Plus the integral from 0 to 2, 3x squared plus 3 dx. Now, that integral isn't a hard one. That's just power rule. So plus, this is going to be 3x cubed over 3 plus 3x from 0 to 2. It's not plus c anymore because now I have limits. Anytime we have limits, we don't do plus c, we do this instead. So that means f of 2 is going to be 4 plus, here's my upper limit, 2 cubed plus 3 times 2, minus my lower limit, which is 0 cubed plus 3 times 0, if I plug all of that in, I get 4 plus 2 cubed is 8 plus 6. So 8 plus 6 is going to be 14 minus 0. And hey, look at that. We still get 18. Same thing, just two different ways. So we're going to do it with this start plus accumulation now, because it's very common on the AP test. Okay, last problem of this lesson, number 15. This is an object's velocity. I want to find the position. So I'm going to set up your start plus accumulation, and then I want you to finish it. So S of 2 is going to be my starting point plus my accumulation from my starting point to my ending point of my equation so let's see, S of 2 equals S of 1, which is 8, plus this whole gross thing. Now, I'm going to give you a hint right now. We cannot do that antiderivative by hand. So this would actually be a calculator question, where for that part, you would just use your math and then your n int. Actually, is it f int? Let me double check. Number 9, f-n-i-n-t. So we're just going to put number 9. And then just plug that into your calculator. That's what I would do. We can't find that one by hand. This would not be a non-calculator question. So if I plug 8 plus whatever that is from my calculator, you would end up getting 24.502. And that would be your answer. So that is your start plus accumulation problem. You should be able to get started on your homework now.